Okay. So as I said, this is probably make or break in so much mathematics from here on in. Whenever we are putting numbers into equations or finding out things, it is very probable we will have to round in some way. Okay? Appropriate rounding is really important. So it seems really silly to have a measurement that is measuring something like this distance. What is that? 70 centimetres, all right? And say that it is 70.3478265498.2. Nothing is exactly 70 centimetres. It's a challenge, isn't it? Nothing is exactly 70 centimetres. We do not have equipment yet that can measure exactly to 70 centimetres. We have equipment in the world that can measure to many, many, many decimal places of a centimetre, but not exactly. So therefore, we're always rounding. We're always generalising. When we say our height, we're not always the same if we're 5'2" or 165 centimetres. We're not necessarily the same. Somebody might be a little bit over, somebody might be a little bit under, but we round to give the answer. When we write up how many people were at the stadium, they do say exactly how many are at the stadium, but they aren't necessarily right. So they would be better to round and say, there is about 21,000 people at the stadium tonight, rather than 21,542, not counting the child that got carried in the person's arm or the people that are working, you know what I mean. So rounding is really important. Way back when, you learnt to round your nice numbers, and you said things like, if you've got $67, what's that to the nearest $10? Would we like to have $67? Even better if we got it to the nearest 10. Why? It's $70. So that would be even better. When we buy things, you sometimes get things for $1.99. But not too many of you would pay $1.99 because we don't have 1 census. So we use what's called Swedish rounding. There's lots of different sorts. But generally they're rounded up or down or whatever. All right, if you're paying cash. But nowadays we all pay with cards, so we can pay $1.99 with card. So what we're going to look at today is not rounding to the nearest 10 or the nearest 100 or the nearest 1,000. We're going to look at decimal place rounding. So decimal place rounding. So what are decimal places? Yep.
Fractions of a whole number.
Easier answer. Where do we find decimal places, Archie?
It's like a number below 1.
Even better. Emma?
The places after the number.
After the decimal point. That's the digits after the decimal point. All right? We call those decimal places. They do represent fractional parts of a number, which is good. I mean, the understanding of that is very good. But what we're interested in today is that they will say something like round to DP. Right? They won't say decimal places. They will just say DP. We know that decimal places, DP is what we use. So if we had a number like 0.04, that's a 7, 421, and we were rounding it to 2 decimal places. 2 decimal places. I'd like some really good instructions as to how I'm going to do that. Go, Wally.
Start off by identifying the 2 decimal point place in the number.
Okay. 1, 2.
Look at the digit after that number.
Okay, I'm going to get lost, so I'm going to put a line in there. Okay, I'm looking at that one.
If that number is below a 5, ignore anything after that line.
Okay, good.
If that number is above a 5, set that
Or
exactly 5.
Yep.
That number that is after the line, or to the right of the line, add 1 to it.
The right to line? Left to line. Okay, perfect. Those are such perfect. Let's write them down. Okay, so count the number. Hayden. Everybody that listens to my videos is going to hear that now. Count the number of DPs we want. Draw a line after that. Look at the next number. If it is, I'm going to write them out, a 0, a 1, a 2 or 3 or a 5, get rid of everything after the line. If 5, 6, 7, 8 or 9, add 1 to the number before. Now I wrote number there because it's not necessarily the digit. All right, so in this case, following those rules, draw a line, look at the next number, it's a 4, get rid of it all. So this is going to equal 0.07. This one, 1, 2, draw a line, 8, it's 8, add 1 to the number before, get rid of the rest, it equals 0.26. This one, is wrong. Is right. Draw our line. 8, add 1. The number before that is 599. So it's going to be 6.00. Now 6 is technically a correct answer, but 6 does not show that you rounded it to get it. Okay, so if you're specifically rounding to 2, if the question was 6, then the answer would be 6. If the question was 6.3, the answer would be 6.3. But in this case, it wasn't 6.00. So we have to round and make sure that whoever's looking at it knows we've rounded. And actually, good practice is to write after it to 2DP so that they know. Okay? So, that is decimal places. The next one we're going to visit is called significant figures. We call this one sigfigs. Not SF, but sigfigs. All right, now, significant figures are used to round very little things or very big things, okay? Because if we were having to do very little things, we might have to say 8 decimal places or 9 decimal places to have something that counts. Or if it's very big, like the distance from here to the moon, we actually don't want to say that it is. I actually have no idea how much it is. Anybody know how far it is from the moon?
300,000 kilometers. 384,000.
384,000. Perfect. All right, so distance to the moon, we've decided is 384,000 kilometers. Okay. Is it?
Not exactly.
Not exactly. What have they done? They've rounded it. What to?
What's this now?
The nearest thousand. They've rounded it to 1, 2, 3 significant figures. All right, so that's the factor 3 sig figs. It's not an exact number, but we don't need all the others because actually in the big picture of that huge big number, they're not important. So therefore, when we're counting significant figures, we start at the first one that's not 0. Now, the reason that I say that, we don't have zeros in front of 384, but if we were looking at the size of a nitrogen, let's say a nitrogen atom, it's on the table, but I don't. Anybody know that? Size of a nitrogen atom?
There isn't a specific amount as the boundaries of the atom are defined by the electromagnetic charges that it produces.
Right, so we think we might round it? We might round it, just to get a general picture, because we're going to say it's about this big. All right, really tiny. This many millimeters. Tiny. This is a tiny molecule, all right? It's not exact again, but if we were going to start counting from here, we'd have it's nothing. And if we're a scientist, we can't have nothing. We need to have something. So we start counting from the first one that's not 0. 1, 2, 3, 4. This is going to be 4 significant figures. Now, zeros that are in our numbers are significant. So these zeros weren't significant because we know that's not the exact distance. But zeros that are in a number, like, can you stop it? What? Yep. That's the second time in my video I have talked to you. Everybody in the world is going to be wondering who that person is. Maybe I should show them.
Yes.
No. They'll be saying yes, yes, yes too, won't you? If we have 302,105 is the population at this particular instance in Wellington. All right? And we want it to the nearest 1,000. Okay? Then we're going to get what? William? 310,000. Well, they know it's not you because I look somewhere different. So they know it's not William. 302,000. That's what you said. Okay, 302,000. How many of those digits are significant? Ollie?
3.
3. 1, 2, 3. That one is not the same as that one. These 3 are. So that 0 is not a leading 0 or a following 0. So that one is 3 sig fig. Okay, hopefully you've all learned something today.